One of the most rewarding moments for a materials engineer is seeing the product being produced on a mass scale. My name is Carlos Barrios, and I'm a materials engineer.
Materials engineers like Carlos work with the structure, properties, processing, and performance of different materials, or stuff, in order to engineer new and improved stuff.
So that's what makes my job so dynamic.
Since everything in the world is made of stuff, there's no limit to what kinds of materials engineers might invent or reinvent. Materials for biomedical applications like artificial skin and prosthetics, high-performance composites for aerospace, even materials for sports equipment and apparel.
You'll find materials engineers working in 3 different venues: government, academic, and corporate environments.
Carlos designs and develops sticky stuff.
As a materials engineer, I'm part of the adhesives group of 3M. So what we do is study different adhesives and we stick to different surfaces. One of the big things for adhesives is using adhesives that last longer, are more resistant to environmental conditions, and can be used in a very small amount. We try to develop new films, thinner films, using technologies as nanotechnology that uses very small particles or use materials that are coming from a biological source. So once we have these new materials, we use them in commercial products.
High-tech adhesives engineered at companies like 3M are used everywhere, from in the home to aerospace, architecture, construction, electronics, and automobiles.
We interact every day with people from different disciplines.
Bubbles coming off indicate that the byproduct is coming off, so the reaction must be going. It looks like everything's going just like we expected.
During the development process, products go through several stages before full-scale production can begin.
Most of the times we start in the bench. We make the material, we characterize it, and we start making very small hand spreads. So once we have these new materials, we prepare films that are becoming new adhesives.
And in this area, you can see the little spheres you were describing, and it turns out they're not fully covering the surface, but they are present.
My wife also works in the materials area, and we like jogging, running, and in Minnesota we have very nice parks and very nice landscapes.
No matter where he is, Carlos is always thinking about stuff.
If you go to nature, you can see, for example, leaves. Leaves are highly structured surfaces, and they are self-cleaning. So one of the approaches that we use now is to try to mimic these properties of the nature to incorporate them into the new products of the future. It is crucial to understand the physics and the chemistry at the surface. You can see here that we increase the volume of the droplet. The droplet basically is sliding at the surface. In some cases, we have very strong requirements in terms of the strength of the material. So we have very specific tests to make sure that we are under the specifications of the design application. One good example of that is the impact test.
Yeah, we have an impact tester that we're able to test at a variety of different conditions. So we can look at very cold conditions, which sometimes make plastics very brittle. And then we can also take it up to higher temperatures too to make sure that it has the wide range of performance that you need.
Once we find the optimum conditions for the materials that we use for this film, we go to the pilot plant. In the pilot plant, we simulate in a very small scale what is going to happen in the factories.
So this is the roll. It looks very nice.
But it has a very smooth pull-off as well.
We need to hear the customer because he or she is the one who's going to use it. So for this, we use focus panels.
I'd say the red one is probably the toughest one to unwind. It stretches a little bit when you're unwinding it.
What we have now is a green light to go to the factories and start making the product in a commercial scale.
Like most research engineers, Carlos loves a good challenge, even when he's not working.
Rustier, rustier, rustier.
My car has been with me for a few years. It's getting old, but I can detect the problems from the materials perspective and try to get to a solution. So something that makes our work at 3M very interesting is that we are a global company, and we have labs and production plants in every single spot of the world. For a materials engineer, it is very important to know what's going on around us, not only inside of 3M, but outside.
In the decades to come, materials engineers will be at the forefront of solving problems on a global scale. engineering next-generation fuel cells, solar cells, water treatment systems, even new drug delivery techniques for fighting disease.
One of the main impacts of the job of a materials engineer is coming with new solutions, for example, for environmentally friendly materials. By doing that, we're replacing materials commonly used, for example, from oil, and try to green materials.
Materials engineers typically hold a Bachelor of Science degree in chemical, mechanical, or materials engineering. Most continue on to get a master's degree in materials engineering.
I worked for a while as a process engineer, but then I wanted to go deeper in the properties of materials, and I obtained a master's and a PhD in polymer science.
When everything has a place to go, it's easy for kids to stay organized.
I'm very pleased to see some of my materials going to scale production. One of the focuses of my career is to develop adhesives that stick to everything, so something called a universal adhesive.
Take a good look at your stuff. Materials engineers like Carlos are working hard to make all our stuff even better, at home and around the world.